Hi, this is Austin. I'm going to cover assignment 3 now. So first is part 1. You can see here that the camera data is only passed in once. The world data is the one that is updated separately. And you can see here my registers to separate those two things out. And I'll run it to show you. As you can see, it still displays as it should, and I have two separate cubes, but only one camera. This is part 2. This one's really pretty simple. It's just the unit pyramid. Here are the places I put the points, and then my construction of the face. This one's really simple. I'm not really sure there's much I can say about it, but I'll show you the pyramid itself. There it is. And those are just the colors that I picked for it. That was just a random decision. This is assignment 3. This one was covering using different colors for each of the rendered objects. And the key part here that I found to make it work was each time you change the data for the world data, you actually have to move the set to context call that was originally in the big giant function at the top. You move it down here, and then it should work properly, and when you're doing that, I was able to get all three to display their proper colors, which I will show you now. So yeah, here we are, my pyramid, my sphere, which I'll get to later, and my cube, each in a different color. So, part 4, this one was about using entirely separate shaders. So first things first, in the actual initialized Imaloc code, I generate the shader, and I just generate another shader. That's pretty much the same code twice. Then we get down to the draw scene, which is where actual different stuff happens. You can see that I'm now setting the shaders here instead of in the initialized demo, since I'm going to be needing to change them on a regular basis. And then I reset them to use the other shader that I created. The simple and select, by the way, are how you can tell the difference. And also the input layout needs to be updated twice. I found that out the hard way. So yeah, I do 2 in the style of the simple, and then 2 in the style of the color select. In addition to that, I also, this is where I did my further work 1. You'll note that I have 2 squares. I'll show that real quick before I continue. So yeah, okay, it was 2 pyramids, not 2 squares, but same difference. You can see these 2 being used with color select, these 2 with the simple color shader that uses the default colors for the vertices. So yeah, 2 pyramids, and if I scroll up, you will notice that I am only initializing 1 pyramid, and what I do is I just reset model 1, which is the pyramid, to use the new context and then draw in a different spot. So that's how I did it. And the reason that's important is because initializing multiple of the same thing and newing it is just a waste of memory, and not to mention the fact that you could potentially forget to delete one of them when there's really no need to remember at all, because if it's only there once, you only need to delete it the one time. I'm going to jump to further work part 2 before I get back to the sphere. So this is what it is. This is a .h file that I prepared with all the different functions. So yeah, has the h result and the my layout, the private functions that I'll show in a moment, the input, the shader and layout input that you need, and then the big 4 all deleted, and then the actual initializer for a shader and a destructor. I also went ahead and did some preemptive C++ work. I have no idea if this works or not. I haven't implemented it necessarily. This was just me spitballing. My idea was to take all the code for initializing the shader and put it into the constructor, as well as having several private functions for some of the more obtuse stuff that would be done in its own separate function. So compile shader from file, I moved here because it doesn't really need to be part of the DXApp as far as I can tell. I also did define layout as a separate function, because the idea would be that at some point this should be user defined, since the user is going to need to change this depending on what the shader is. Otherwise, this is all the same construction code that was in DXApp, slightly edited to make it work as a separate class, and then the destructor to clear out the shader and the input layout. Last but not least, we have the sphere, which you can see that I'm only initializing one object, and I will actually go ahead and open the sphere now, because it's pretty complicated. So here it is. So first things first, I initialize my vector, which I'll be rotating. I initialize my rotation matrices, and then the angles, which I probably should have given better names, but I digress. Yeah, so vertex and index buffers, just because I'm going to need those. So my vertices loop is not too bad. Basically, I generate the top point. I generate all the points in between by rotating X, going through that horizontal slice with rotate Y, and then once that horizontal slice is done, I rotate by X again to move to the next one, and then generate the points. And then the triangle indices, so I generate the top part separately because it uses a single point as the top for all of the triangles, and that's important. So I just loop through making that triangle and then make the last one differently because it loops back around to the beginning of that slice, so it uses different coordinates in this one. Same basic deal for the bottom when I get there. The middle stuff is where it gets complicated, and essentially what I did was I went through and hand-made some of the vertices, figured out what the patterns were, and then coded them in here itself. So the way it works is each time you get to the last triangle in a vertical slice, it does the code differently, but up until that point, it uses this, it uses these coordinates, and this will be correct no matter what number you put in there. I did test that, and I will show that as well. Okay, so here's my sphere. It's all black, just because that was easy. So, yeah, there it is. I will now go, last but not least, I will go into the actual model for where the sphere is generated and change these to, let's say, 4 to make it obvious that it's different. Compile that. And yeah, you can see, same deal, 4 slices, and there it is. So, that's everything.